Hey guys, Bobby Thompson here, back with another video. I'm currently working on a series of short videos to help newcomers to flat earth cosmology to understand the different flat earth arguments. I realize this information is out there many times over, but this content is being made for my own channel and I didn't want to risk a YouTube strike. So without further ado, let's jump into craters, meteors, and asteroids. We'll start with some quick definitions. An asteroid is a small rocky body orbiting the sun. Large numbers of these, ranging in size from nearly 600 miles across to dust particles, are found especially between the orbits of Mars and Jupiter, though some have more eccentric orbits. A comet is a celestial object consisting of a nucleus of ice and dust, and when near the sun, a tail of gas and dust particles pointing away from the sun. A meteor is a small body of matter from outer space that enters the Earth's atmosphere, becoming incandescent as a result of friction and appearing as a streak of light. A meteorite is a meteor that survives its passage through the Earth's atmosphere, such that part of it strikes the ground. More than 90% of meteorites are of rock, while the remainder consist wholly or partly of iron and nickel. So if you were to do a Google search for a crater, or an impact crater, or meteorite crater, this would be a typical result. These images came off Google, and you would get a whole page that looks similar. They all share the same two characteristics, and one of those characteristics is that the crater looks like it was hit at a 90-degree angle. So it doesn't show any sign that it was hit from a side angle or an angular impact. And there's no sign of a meteorite there. And if there is, it was super tiny, or 99.99% of it just disintegrated, right? So what we would expect to see is an impact like this more commonly, right? So I don't know what movie this is from, but this is more realistic. You would expect to see, certainly more commonly, angular impact craters. Let's talk about Halley's Comet for a minute. Real quickly, Halley's Comet does its orbit around the sun once every 75 years. It was last closest in 1986, and it's projected to return in 2061. And in order to believe in the science behind all of these things, and right now we're talking about Halley's Comet, you have to believe that it maintains this wildly elliptical orbit. So if you listen to astronauts or physicists discuss what an orbit is, they will describe it as the act of falling around an object you're orbiting, right? So basically you're caught in the object's gravity, and you're being pulled to it, but you're falling away from it as fast as you're getting pulled to it, right? So you're in this constant state of falling. And if that is truly the definition of an orbit, then how do you explain this? How do you explain a wildly elliptical orbit? I'm assuming this is millions, if not trillions of miles. I would assume millions of miles, but here you have Halley's Comet swinging around the sun, clearly being thrown away for millions of miles, and then all of a sudden it starts falling, right? I mean, is this falling? The way you understand how an object in orbit falls around the object it's orbiting, is this falling? So in order to believe in the science of asteroids and comets and meteors and meteorites, you have to believe three things. You have to believe that all of this space debris hits the Earth at a perfect 90-degree angle. You have to believe that that debris disintegrates, or at least 99% of it. And you have to believe in these wildly eccentric orbits that make no sense, right? It doesn't make sense to me. So thanks for watching, and I'll catch you in the next video.